Is everybody familiar with Energy Star, at least the logo? Okay, good. That jives with what 90% of Americans say, which is that they recognize Energy Star. And curiously, not a full 90%, but like 85% have a good association with Energy Star. So that's one thing AJ might mention later, that being associated with this brand has been found to be helpful for organizations and companies because it's a recognized brand and it's a respected brand. Energy Star has, you probably know, like refrigerators, right? Products in your home. Most people associate Energy Star with that. We actually also certify commercial buildings as well as homes. You can go buy an Energy Star certified home, which would be warmer than here on a day like today, because those homes are generally 30% more efficient than a home built to today's code. But today we want to talk a bit about our industrial plant side of the program, because that's more appropriate for you all, although we can certainly answer questions about the others. Energy Star for Industry has worked with a number of partners in the industrial and manufacturing sector for a number of years. One of our favorites is the Titan Roanoke Cement Plant, which is outside of Roanoke, Virginia. They fully embraced the Energy Star program and use that to guide almost a complete overhaul of their process over a number of years, to the point where for 11 years running, that plant has been certified as an Energy Star certified plant, which means that it's performing at a more efficient rate than 75% of all other cement facilities in the country. And they've received accolades from EPA, and obviously they've taken pride in every year when your building or plant is certified, you get it used to be like a really nice bronze plaque, and then the government shrunk a little bit, and it became like what I call a window decal. It's supposed to look like etched glass on a window. It never looks like that. But anyway, when we were giving out the bronze plaques, they hung all the bronze plaques at the entrance to the plant. For Roanoke, what was important to them was the mentors that they could access through Energy Star and the information we provided. And as I mentioned, they used that to guide sort of a whole system efficiency rebuild process. Other partner of ours is Merck, who I'm sure you've all heard of. For them, it was a little bit different. They wanted to save money using our programs, and they wanted to meet certain greenhouse gas emissions reduction goals. So everybody's got different priorities. Energy Star tends to fit a number of those. So in terms of being recognized by Energy Star, there are a couple of ways to do that. We have a partnership program. You can join Energy Star as a partner on behalf of your organization. That partnership is free. You generally make, I don't want to say a generic commitment, but kind of a baseline commitment to improve your energy efficiency over a certain period of time. If you do great and you educate your clients or your customers or your partners, you can apply for an award through Energy Star. It's a national award. You'll be recognized in Washington, D.C., where it's warmer, and you get all sorts of bells and whistles. Your website, our website, that sort of thing. The Roanoke example I mentioned, they became a certified facility. So rather than trying to do this big partnership effort, they focused in on their specific facility and improving that, and they obtained Energy Star certification. And today, what we're going to spend most of our time talking about is what we call the Energy Star Challenge for Industry. And rather than give you an overview of that, I'm actually just going to turn things over to AJ, who is our Energy Star for Industry expert, and she'll walk you through that.
All right, so as Andrew said, today we're here to talk to you all about the challenge for industry. So what is this challenge? It's a 10% reduction of the energy intensity of the site within 5 years. So a brief overview. This is open to any industrial manufacturing site. So you can customize it to which site you want to use. It is a 10% reduction in your baseline year that you also get to select as a manufacturing plant. And this baseline is based on a 12-month marketing period. So you're tracking your energy data for a whole year, and then that number is what generates your baseline data.
Electricity and natural gas?
Yes. So you convert, the next point is the intensity metric is determined by the folks that are in the plant. So you convert all of this energy information to BTUs, so that's able to normalize all of the data across all of the energy consumption throughout. And you also get to choose whether you would like this information to be the metric to be by unit of production or by square foot, so that's up to the plant themselves. And no annual reporting is required, so it's very self-monitored. The EPA isn't going to come at you every year asking for a progress report. You just report at the end of your 10% reduction. And the only required step is this verification for to apply for recognition at the end, so once you've completed the 10%. So what are the benefits of completing this challenge? So your company will receive a certificate from the EPA that congratulates the entire company on their hard work and the achievements that they've gone through. You also have access to a variety of communication materials that are available online. I'm going to go into more detail on some of those later, but there's a variety of tracking tools that you can use, energy management guides, so it kind of opens up your eyes to all of this different information instead of having to reinvent the wheel every time you're creating your strategic energy plan. You also have the opportunity to be profiled on EnergyStar.gov. So just by committing to the challenge, your name is on the Energy Star website. Once you complete the challenge, you are now put on a different website where you're put with the list of those folks who have achieved the challenge. And this example on the right here is the Danville facility. It's a tape manufacturing facility, and they have a whole profile on EnergyStar.gov, so other folks can see information about your facility and the different energy management achievements that you've gone through.
Do any service companies actually access your website for that list when they're looking at?
Yeah, anyone can see any of the profiles for anyone that's either any of the folks that have participated in the challenge or achieved the challenge have these profiles online.
And that's, just to add, that's a nice thing to have, because as EPA, we can never endorse a company or recommend a company or a partner. So the best we can do is say, go to our website for a list of people who are partnering with us in these different efforts. And that gives them leads, and it's sort of like an endorsement, but not really. You know, they're verified as having worked with us. So it's nice to have that place on the website.
Because some, if you're green, they want to work with companies that are green. So I was just wondering, do you have requests?
Oh yeah, no, we'll get them from time to time. Yeah,
direct them to the website.
Yes, and one of the things related to this that we aren't talking about is a service and product provider list of organizations who have used Energy Star tools, and so that's on our website as well.
And these lists also help with potential mentor-mentee kind of programs, so larger scale companies can say, these are the different programs that we've used and the steps that we've taken, and kind of that helps with partner of the year. It's kind of a different scale of things, but you can see what other folks are up to. And also a letter to the CEO from the EPA, so it's just another positive recognition of the effort that the plant has gone through, and also, as Andrew was saying, with that positive recognition with the Energy Star label, you are able to attach your company's name to the label. So what is the process to go through this challenge? So the first 5 steps that you can see from this list are all getting you ready to register for the challenge. So steps 1 through 5 are pretty simple. So quickly going over each of them, if anyone has specific questions on things, I can help you with any of those. But so the first step is to identify your energy intensity metric. As I was saying before, that is determined by the plant based on the site energy load. So if you're heavily production-based, you would do the BTUs per production unit. If you have more sites, like if you want to do it by square footage, if you are heavy on heating and lighting, that sort of thing, that's kind of how you can customize your challenge tracking by using this energy intensity metric. The second step is to select the tracking method, which Energy Star has a variety of different tools that you can use to help with this tracking. There's an energy tracking tool that's available online. There's this EPA, which is an energy performance indicator. That's another tool that's available online. Or if you're using per square footage, you can use Portfolio Manager, which I'm sure some of you are familiar with. The third step is to set a baseline and the 10% improvement goal. So that's where you're gathering up all of your information and you are creating that baseline number for you, and then the 10% reduction is then your goal from that point. Step 4, create a formal site file and a plan for tracking the data. This is just an organized way for that we require so that folks have an easier way to apply for the verification at the end. So we're just making sure that everyone's keeping their energy data together and kind of creating a organized system for tracking. And then step 5, register for the challenge. It's very easy, it's online, simple to do. Step 6, track your energy use and achieve the 10% reduction. So the tracking of the energy use is by whichever of the energy intensity metrics that you select. And then step 7 is to verify your energy savings and apply for recognition. So this is the part where this is the only mandatory information that's needed to be submitted to the EPA and approved by a PE. A little bit more information about who's taking the challenge. It's been taken by over 1,300 sites. Achieved the challenge, it's 426 have achieved the challenge, and 280 sites have actually achieved the challenge twice. So these.
So why, why is it less than half actually achieved the challenge? What reason?
For actually, I think with either following through on the energy management plan, but so a lot of the folks that actually have achieved the challenge, that 420,
Right.
more than half of them were able to go back and re-register for the challenge and find another 10% reduction.
So, and there could be, of the 1,300, there could be companies in there that are still in process. They're still in
Yes.
that 5-year
Oh,
period.
Either
Just
still
achieve
taking
again.
it,
Yeah.
or they've, so that includes folks that have taken it more than once, or things like that, like over a long period of time.
And it's 10% over 5 years, but if you achieve it within 2 years, then you
Yes,
get, okay,
yeah.
then you can, you know.
So yeah, like the 10% is the hard stop almost, like if you can achieve it in 2 years, you can achieve it in 1 year.
Okay.
It's just once you find that 10%. And it's also taken in over 50 countries. So the parent company needs to be associated, it needs to be in the United States, but a lot of folks have used this for plants in Canada or across seas and things along those lines. So it's very universal. This chart is the sector participation in the challenge. So these are folks that have achieved the challenge. And just gives you an idea of the sectors that are highly involved in the challenge itself. Like as you can see, motor vehicles is by far the largest participant. But a big thing to notice on this chart is the average reduction versus the average time. So as we were saying, it's a 10% reduction in 5 years or less, but the average reduction is actually around 20% in 2 years. So these folks were able to find a much higher reduction rate than this 10% promise.
And you don't have to be in one of those sectors.
Oh, no,
to
these are just the
participate.
top
They're-
7.
Yeah, those are just the
Yeah.
most, we have the most achievers from those sectors.
And this is a similar chart. This is those who are currently participating in the challenge. Same thing that Andrew just said, you don't have to be in one of these categories to participate, but these are just the big, heavy participants in the challenge. So these are kind of the big name folks that are participants in the challenge. I'm sure all of you can recognize more than half of the folks on here. We actually have 2. This, or is he, I'm
I
not
know.
gonna.
How do you pronounce that? Do you guys know that?
Arista?
No.
It is Arista?
It is Arista? Okay.
Rista and
I
Bimbo
wasn't
are
even
both in
gonna.
this area.
And the Bimbo factories, these are both located in the
companies.
Hazleton area. Yeah. So this is just an idea to get all the big names that are using the challenge, and it's highly used. Over 73 trillion BTUs have been saved. Energy savings by achiever plants equals the total annual use of 470 some households. And over the 7 years that the challenge has been used, it's saved over $371 million in energy costs, which if you divvy that up by the folks that are the 420 some participants, it's around 800.
Yeah, it's like $800,000 on,
Average.
so, right, so if you look at all the 420 sites that achieve the challenge, and you divide, you do the math between the 371 million and the 420, it's like 800 and some odd $1,000 average savings, which isn't, obviously they're all different sizes, not everybody saves that much money, but that's a significant amount.
And there's a handout that I put on each of your seats, and it kind of breaks down those numbers a little more. And they have it by 2016 numbers. They have what's this converted into a factory worker's wage. So it really helps to put a visual on the money that you're saving. So how are the achievers doing it? Last year, the EPA sent out a survey to all of the challenge participants with kind of an idea to get a good idea of how they best were achieving the challenge. So as you can see, like the top third use utility incentives and rebates. So PPL in this area has a bunch of different rebate opportunities for either fronting costs on projects or things along those lines. External consultants that have these energy treasure hunts is a guide that we have online where it's energy managers and workers in the plant can go into the plant on a Sunday when it's low operation, and then on Monday when it's on kind of a normal day, and you walk through the plant, and it's a fun play on a treasure hunt, and you look for, is there a better process that can be done here? What are ways that we can work together, the energy manager and the folks that are on the floor every day, but what can we do to either reduce our energy consumption or just make things more efficient in general? The same thing, we have industrial energy guides available online, industrial assessment center, so PennTap has different rebates, and they have energy assessments for free.
Has anybody here worked with PennTap before? Because they do free,
Yeah.
I think they do a free assessment.
They do free, yeah.
You have? Okay.
So there's a lot of information for them online, and I'd be happy to send that to anyone who's interested. So just a quick recap. Today we presented with a free program. It has free resources. There's no need to reinvent the wheel. No penalties if you don't achieve the challenge in 5 years. I don't think that I really harped on that enough. If you don't achieve the challenge, the 10% reduction in 5 years, you can re-sign up. You don't need to re-sign up if you don't want to, but it's something that's very at your own pace. You can customize the challenge to how you want to complete it. It offers the possibility for recognition and cost savings, which is huge, and it's a way to help member companies remain competitive in today's business world.
Over the last couple of weeks, I've been speaking with AJ and Andrew over at the EPA, and with Energy Star certification, makes perfect sense to get recognized for reducing your energy consumption, doing what's best for the planet, but also reducing your costs for your facilities, as well as becoming more efficient. So ultimately, it's the bottom line. You're increasing your profitability of your buildings when you become Energy Star certified. So efficiency. So Energy Star certification, how do you achieve it? What tools do you use to achieve Energy Star certification? And previously, over the years, or technology has changed, but a lot of you have probably had energy audits over the years, which folks come into your facility, they take nameplate data information, and they reverse engineer the utility bill and make a lot of assumptions as to what's going on in your building. And those assumptions are somewhat accurate, but they change every day. So depending on how your building runs, your efficiency may change every day based on your process. So what tools can you use to manage and measure the energy usage in your building? One of the things that we like to look at when looking at and monitoring and measuring energy is behavioral issues, human behavior. Human behavior can actually cause a lot of waste within a commercial building, within a manufacturer, leaving pieces of machinery on, lights on, and then equipment and efficiencies. If you have an older facility, looking at your motors, your pumps, and benchmarking those, maybe some of your newer equipment to see what's the most efficient piece of equipment in your facility, and ultimately failure prevention. So I stole this slide from AJ and Andrew because I thought it was the steps were, it was compelling as to what I wanted to discuss today. So to go through this challenge, you have to implement some kind of tool or process to measure, monitor, manage, and analyze your data. How do you know you're reducing your usage by at least 10%? And how can you become more efficient to do so? So technology has changed. We all have iPhones, right? Smartphones. They come out every couple of months. You buy a laptop. It's already outdated 3 months after you walk out of the store with it. Energy management, energy monitoring has changed also significantly in terms of the technology that is used both on the hardware side and on the software side. So now, instead of those big clanky wired meters or data loggers that may only last for a few weeks at a time, you put them on a piece of machinery, you read the data, and then you take them off, they become ineffective. Now, there's tiny wireless self-powered and very inexpensive hardware out there that has completely changed the landscape of energy management and energy monitoring. Very fast and easy to deploy. I'm not an engineer or an electrician, and I can install this in the facility. That's how easy this is. So on the left, as you will see, our process is called SiteWatch, but in comparison to wired solutions takes 1 or 2, 3 days to wire in sensors into your box.
You have to turn the power off.
Shut your power off, shut your processes off, change your scheduling. With the SiteWatch wireless sensors, ultimately within an hour you can put 50 sensors in your facility within an hour without shutting off a piece of equipment. They're wireless, they're self-powered, and they're easy to deploy. So how this works, how does this technology work? Very, very simple. Ultimately, you clamp on the sensor into your box to measure that circuit. The information is then sent to a router or what we call a bridge, and then that data is then transported up into the cloud, into whatever software that's in place. Very simple, and you know, when it comes to time, once you put this equipment in place, immediately within seconds, you're managing, monitoring, and measuring your energy usage within your building.
We have some of the little sensors on this magnetic board back here in one of the bridges.
Yeah, you go back there, they're magnetic, you can kind of move them around, pick them up, check them out, look at them, feel free. So understanding your energy use. So with the hardware and software, there are multiple ways of pulling in the data and looking at it in a graphical representation. Nobody likes to just look at numbers. Right? It's nice to look at a picture of your data. And this particular graph is called a heat map. And ultimately, it's looking at the energy intensity during the hours of operation of a facility. This is actual data that we have pulled. And it's a 24-hour look at a facility over, I think it's 2 weeks there, 3 weeks there. Can't really see very well. And as you can see, the red is indicating the most intense energy usage for that facility. So it's a 10,000 foot view of the facility. So it's not very specific to a piece of machinery, but you can see how energy is being used during hours of operation.
And why is some being used when the plant isn't operating? You know, there's some energy use when supposedly the plant's closed. Is that security, the cleaning crew? I don't know what it is. And why so red in 1 week and yellow the next week? Bad scheduling or end of the month? But
Large, maybe it was, you could look at it and you know your facility, maybe it was a large order, a large production run, right? So you can see where your energy intensity is for the building. So actionable results. Now this graph here is actually showing a large system air compression unit at a aluminum foundry, actually in PPL, not too far from where we are here. And as you can see to the far left, during hours of operation, that pump is cycling to keep up with the work that's being done in the plant. But after 1,300 hours, work's done in that facility. And now they keep the air compression unit running because they don't want condensation in the lines to affect the pressure of the building when they open up the next day and get back to work. So they leave the compressor running, but as you can see, it's constantly cycling throughout. And if it's always going to cycle slightly, but it should be cycling minor cycles, not these giant spikes to build up pressure in the unit. Here, what we learned was that the air compression unit had leaks throughout the whole system, so it had to keep cycling over and over and over to keep a baseline pressure during off operation. And you're looking at an annual cost just in leaks of $25,000 a year. So if you were able to address this, almost within a few months, you can get Energy Star certification because you reach your 10% just by addressing one piece of equipment, one system in your process.
Well, but also, I mean, everybody knows air compressors leak, but you wonder how much does it really cost you, because it's going to cost you $5,000 to fix it. Well, if it's $25,000 worth of leaks, they get it.
Well, and your return on investment.
Yep.
So having an engineering firm come in, do a survey, and fixing those leaks, if it costs you $10,000–$15,000, but you're wasting $28,000 a year, your return on investment is instantaneous. Once that project's done, there's your return on investment. You fix your leaks. Now you're not bleeding $28,000 a year in air leaks in your facility. Data-driven decisions. So nameplate data, it's great, right? But again, it's assumptions. It's looking at voltage. It's looking at amperage, hours of operation. You don't really know exactly in real time what that piece of equipment is using in real time. And looking at your facility, there are a lot of things you may want to measure. And in this case, we're benchmarking 4 different motors within a facility, okay? And we're showing here is this motor 1 in the bag house, is using much more energy than all the other motors doing the exact same process. So there's multiple motors doing the same process within a bag house. So if you're looking at becoming more efficient in your process, now you have benchmark data, and you can say, all right, does it make sense for us to replace motor 1? Or if, depending on the production, is it better for us not to use that line during larger production for that bag house? Maybe you shift from that process over to another process doing the same thing because it's more cost efficient. So you can look at it for scheduling purposes and replacement. So equipment failure alerts. What's really neat about energy management and energy monitoring, when a piece of equipment, a motor in particular, is getting ready to fail or starting to fail, it tends to start using more energy because it's working harder, right? There's voltage and amperage increase for that motor to do the same job it typically does. So you can set parameters and benchmarks and receive alerts, whether it's to your phone, your desktop, as to is that piece of equipment working within that threshold. And when it goes above or below that threshold, you get alerts instantaneously as to what's going on with that piece of equipment. In this instance here, it was a purified water pump that just stopped working. It tripped, and it just dropped. So somebody needed to see this data, got an alert on their phone, or their laptop, or their PC. Now they can address the problem or know what happened if something happened in that process that went wrong. Now they know, well, the pump tripped and it completely stopped working. So my question here, who here manufacturing from a manufacturing facility. Question for you, have you ever had a failure of a motor or a process, maybe at the most unopportune time? Right? And how much? Always, right? It's Murphy's Law, right? And it always happens to your biggest production, your biggest order, or you're on a timetable and you have to get that.
For our university clients, the air conditioning goes out on graduation day.
Graduation, correct, right? And how much time does that take you in terms of downtime? Significant amount. Sometimes you have in-house folks who can fix the problem. Sometimes you have to have somebody come in, you're ordering a motor, you have to wait till it's shipped, and that motor comes with an engineer with it, right? And then that engineer, they're installing it themselves, and that's gonna take time. A whole week, 2 weeks can go by of lost production over a failed motor. Well, if you can see this immediately,
Or watch a trend.
or watch a
Watch a
trend,
trend, you
go
know,
up or go down, right? You could be proactive.
I mean, there's actually a
and start
case to be
addressing
made for
those-
doing preventive maintenance rather, not on a schedule, but as required by each piece of equipment.
Right. And hopefully, you know, you can fix it during those shutdowns during Christmas and 4th of July holidays, right? So machine health, we touched upon this. Earliest signs of machine deterioration, you know, exceeds preset energy consumption. Pieces of equipment are running longer than they're supposed to. Compressor short cycles, which we showed earlier, and electrical phases are not in sync. This is interesting. We put a system in place at Aluminum Foundry that's everything piece of equipment's a 3-phase in their building, all their furnaces. Well, immediately we noticed that their ovens, the heating elements were only working off of 1 or 2 phases at a time instead of all 3 phases. So instead of all the heating elements in the furnace working together, let's say there's 6 of them, only 3 were fired at one time. Well, now all that pressure of only 3 heating elements running to maintain core temperature in that furnace, those heating elements are going to fail, and those are expensive. And the other ones aren't doing, they're just sitting there, and those are expensive. So that was an immediate find within, I would say, what we put the system in within 24 hours. I think we found that their furnaces were running off of 1 or 2 phases. And the thing is, sometimes it would run off of 1 phase, and then an hour later, the second phase would kick in, but it wouldn't ramp up to all 3 phases for that furnace. And investments in new equipment. So how do you determine what your return of investment is? Nameplate data, which is very inaccurate, or real-time data? Actually being able to measure new equipment with old equipment. You put in a new boiler, let's say, you can measure that, right? Boiler's not a good furnace because of the whole flow thing, right? With natural gas. You put in a new arc furnace. Well, you want to know what your return on investment is for that piece of equipment, which could have cost you $1 million to install. And what is your return on investment on that piece of equipment? Now you have real-time data, and you can compare it to the old furnace.
Great M&B tool.
Right, and great tool. And prior, hopefully, you're monitoring, measuring, and analyzing your old equipment before you replace it, instead of just going by nameplate data. So, looking at an energy management process, system, however you want to call it, you want to look at a few things here. How fast and easy is it to deploy? Do you need to have outside electricians in your facility, or can your own guys put it in? Do you have to shut down operations multiple days to put it in? Do you have to have guys come in after hours, which we all know costs more than during hours, right? You guys got guys coming in at midnight to fix things. Well, that costs money, and it's more money for those guys to come in at night. It's inexpensive to buy and operate, easy for operators to use. We all have smartphones. We want something that's intuitive. We want something where we can look at it and almost immediately pinpoint what is going on in my facility, right? We don't want to read manuals. We probably have enough manuals already to read and already know regulations and laws and all sorts of stuff in your facility, last thing you want to do is study a manual. Data visibility, flexible reporting, and control over volume of information. If you want robust data, if you want a lot of granular data, you have it. If you want a holistic view, you can have that as well. So you can really set up what you want to look at, what you want to measure, and how it's presented to you in a very simple and easy way to understand.